We're going to do some practice AP problems. You guys know my addiction to getting new practice books and going through and trying to do them as soon as possible. So what I did is I came up with some problems, and I'll probably split this up into 2 videos so that each one doesn't get too long, where they were multiple choice questions. I'm going to put at the top, are you allowed to use a calculator, are you not allowed to use a calculator, and just kind of go through them with you so you have a chance. If you want, you can pause it, read the question, see what you think, and then you can play it and see what the actual answer is. And I tried to pick questions that were not very direct. I didn't want to give you a question that was just find the derivative or find the integral. Wanted at this point in the year to try to look at some of the ones that maybe were a little more complex or a little bit more abstract. So this first question is a related rates problem, which I know is something we have not done for a while, so it'll give you a good chance to do a quick recap. We are doing related rates where we're comparing the rates of the circumference of a circle, the radius of a circle, and the area of a circle. So we actually have 3 things happening here. So the first thing you want to do is you want to make sure you know your geometry formulas. They will not give you any type of circle formulas. So circumference of a circle is 2 pi r. Area of a circle is pi r squared. They tell us that the circumference is increasing at a rate of 0.5 meters per minute. That is your dc dt. So you might want to kind of label that or circle that as you start. So the first thing I did is I derived circumference. I get dc dt equals 2 pi dr dt. And then I'm going to plug in what I know, which is 0.5. So 0.5 equals 2 pi dr dt. I do not know dr dt, but what I can do is that's the only thing left, so that's what I'm finding. I'm going to divide both sides by 2 pi, and so I'm going to write my dr dt, and it's going to look a little funny here, but I'm going to write it as 0.5 over 2 pi. You could simplify it, but I don't have a calculator that I can use, so I'm just going to leave it as is. Next thing I'm going to do is I'm going to go over to my area function, and I'm going to derive that. So I have dA dt equals 2 pi r dr dt. My goal is to figure out dA dt. So because if you read the question, it says, what is the change in area? So I want that how that area is changing, that rate. I'm going to plug in r is 4. They give me that piece of information. I'm going to plug in my dr dt in kind of the not simplified form, but you'll see in a second it's kind of nice that I didn't simplify it. I get 0.5 over 2 pi there. Because I didn't simplify, I can very quickly cancel the 2 pi and the 2 pi here. I get 4 times 0.5, so half of 4 is 2. So that tells me my area is changing at a rate of 2 square meters per minute, and that gives me letter A. So if you went through this problem and got A2, you are correct. Next question is also a non-calculator question. I thought this was one of the toughest ones that I went through when I did some practice problems. We recently did a complete U substitution. This is very similar to that, but it was a little harder, so it was kind of just taking what we've done in class to the next level. First thing I did was I wanted to see my boundaries, because I know if I check my boundaries, I can eliminate some options right away. So if I know that u is radical 2x, and that means when x is 2, I put 2 in here, I get the square root of 4, which is also 2, so u is 2, so my bottom boundary does not change. And then when x is 8, put 8 into my u equation, I get the square root of 16, which is 4, so my boundaries should be 2 to 4. So first thing I would do on this problem is I would cross off this one, I would cross off this one, and I've got 3 left. Next thing I want to do is I want to see what the adjustment is here, and that's where this problem becomes a little more difficult. If u is the square root of 2x, then du is a chain rule. Power out front, power 1 less, derivative of what's inside. I'm going to cancel the 1/2 and the 2, and I'm going to move the 2x to the bottom, so it's going to look like this. And when I first started doing this problem, I was trying to think about I was thinking more of a constant adjustment. That's not actually what's going on here. What's going on is I need to replace this dx with something in terms of u. So here's my dx. What I'm going to do is to get this by itself, I'm going to multiply both sides by the square root of 2x. And I need to be in terms of u, so I'm going to use what they told me up here, the idea that the square root of 2x is equivalent to u. So I'm going to write u du is equal to dx. Very more involved complete u substitution. So now when I look at my problem, I'm going from 2 to 4. My dx is going to be replaced with u du. My denominator is going to be replaced with u plus 1 because I know radical 2x is u. I look at my choices. The only one that has the right boundaries and the right piece in the numerator, really it was the numerator that you had to figure out, is D. Tough problem. I thought when I went through this problem that there were kind of a lot of twists and turns that you could take here to have trouble finishing it. Hopefully everybody is comfortable with the boundary and making sure those switch, and then from there you're looking to see how we do that du and dx adjustment. Next problem is a calculator problem, so you are allowed to use your calculator, although it's not going to be a huge help to you, but at least it'll give you a little bit of visual. What you'll notice is the problem has not been finished. It's just a setup only, so that's why the calculator, it's a help, but it's not a necessity. Problem wants to find a revolution volume. We are revolving the graph of the region between y equals 9 and y equals x minus 3 squared around the line, oh, I think I didn't put that, region bounded by... it's going around the line. I've left out part of this problem. It is going around the line y equals 9. So we're taking the region between y equals 9 and y equals x minus 3 squared. We're revolving it around the line y equals 9, and we want to see which integral represents it. So first let's get a little bit of a visual, and if it helps, you could do it on your calculator. So I'm going to go to y equals, I turn my plots off from the last thing I did. So I'm going to graph 9, and I'm going to graph x minus 3 squared. You should know that that's a parabola. It's been shifted over to the right. So there's my 9. There is my parabola. To see where they intersect, obviously you could use your calculator or you could just set them equal. Does not matter because you are allowed to use a calculator. If you square root both sides, you get 3 equals you get plus or minus 3 equals x minus 3. So when you add 3 to both sides, they intersect at either 0 or 6. I did draw a little sketch to help me on my paper to try to see what's going on here. My axis of revolution is y equals 9. So I actually do not have a hole. This is a disk method problem. My radius is top minus bottom, so my radius is going to be represented by 9 minus x minus 3 squared. So I started looking at choices, and at first I was thinking that the choice wasn't there. It didn't quite look right, because I kept focusing on the fact that I was going from 0 to 6. And what it should be is I should be going from 0 to 6 pi, and then it should just be radius squared. So my radius is 9 minus the quantity x minus 3 squared. That has to be squared. And I was looking for that choice, and I went through all of them and thought, I don't see that choice. So my next thought was, I have symmetry, and I don't always use it, but in this case, if you do use it, we actually could split this up from 0 to 3 or from 3 to 6 and double it. And that's actually what happened here. When you look at your pieces, you need to have your radius squared, and this one has the right radius squared. This one squares the pieces individually. It's just a single radius, so that's the problem with this one. This one has the subtraction in the wrong order, and it's squaring them individually. This one down here forgets to square the whole quantity. It only squares the x minus 3, and this one has it in the wrong order. So the only one I had left with was B. So to figure out what they did in B is they chose, instead of going from 0 to 6, they decided to use the symmetry and go from 0 to 3, and then double it. So that's why you see a 2 in front of the integration symbol. It does have the correct radius, the idea that it's a single radius. This is not a washer method. It's a single radius, top minus bottom, 9 minus the x minus 3 squared, and then you have to square that entire radius. So this is another one that you were allowed to use a calculator, although it really wasn't a huge help. But it was a little more involved because they chose a different way to write it. And they weren't just getting an answer that you were getting the definite integral answer. They were trying to just see what would the setup look like. Here's one more we'll do on this video, and then I'll make a separate video for the next problem. This is also a calculator problem, and this one wasn't too bad, but it definitely was a calculator active type problem. It wanted to know if f is this function 3 plus the integral from 0 to x of cosine, when would be the least positive number when the derivative would equal 0. So the first thing I need to do was derive it, and this is that fundamental theorem of calculus once again. When I derive 3, I get 0, so that's gone. When I derive the integral, I get cosine of x squared. and I want to know when that equals 0. And the reason why the directions say the least positive number is what we know about trig. We actually can get a lot of times when cosine equals 0. You can go around and around the unit circle. It wants the first positive one. So what I did is I want to figure out when will cosine equal 0. Now the nice thing here is I could use a calculator if I wasn't sure. I do know that the cosine equals 0 at pi over 2. So what that is telling me is that my angle x squared has to equal pi over 2. Obviously, it happens a whole bunch of other times. It happens at 3 pi over 2, and it continues to happen. But I want the first one, that first positive number, because I'm looking for what the directions said. My next step is to take the square root of both sides. I don't have to worry about plus or minus because they are looking for a positive number. Here's really the only time I use my calculator on this. Not that you couldn't use your calculator to help you with a trig if you need it. I went to my calculator and took the square root of pi over 2 to get the answer of 1.253. And there it is. So it's calculator 1. Essentially, the only thing the calculator is a necessity for is the very end. So this takes you through 4 problems. You got to do 2 with your calculator, 2 without your calculator, a variety of problems. None of them I would classify as easy problems. All of them had a little bit of a trick to them or something that made it a little more abstract. Hopefully these problems help you whenever you're getting ready to take your test.